Hello, everyone. I'm a data scientist, I'm a blogger, I'm a YouTuber, and a corporate trainer. Most people that go into data science aren't from an actual data science background. In 2011, I started college. From there, I didn't program at all up until mid 2014. And then from there, I worked as a MATLAB intern at Cymer. I started a data science master's in 2015. And then from there, I was an intern at CME Group. I worked at a company called Uptake. I became a business analyst at Damon. And then from there, I moved to Scripps. Okay. So one of the big themes of this talk is really just how to make a portfolio, how to get a job, and how to make yourself more appealing to industry. I worked at the Nanobioelectronics Group. What I did over there was really a lot of very academic work, like steering red blood cells with ultrasound. I worked at NASA Ames Research Center in 2014, making a cryogenic chamber. And then all of a sudden I had a giant shift into programming, into data analyst roles, data scientist roles. When I was in nanoengineering, ironically, there wasn't a lot of work. You got to be able to pay the bills. You see all these articles like data scientists, the sexiest job of the 21st century. I chose analytics because, frankly, there's work. There's always data, so there'll always be something to do. There's always a challenge. And one thing I never really considered when I was doing my undergrad is a lot of jobs allow you to work remotely if you can program. How do you get into a field that you weren't in previously? The barrier to entry in a lot of fields is relatively high. A big part of getting a job is having some sort of portfolio. First of all, you have to have a resume. Most people have one. LinkedIn helps. Having a good online presence really helps you a lot. As a programmer, as a data scientist, as an analyst, it really helps to have a GitHub, and we'll get into what that is and why you need it. If you're in business intelligence, and let's say you do Tableau, it's good to have a Tableau public to be able to showcase your work. Additionally, you got to network, okay? People always say that the easiest way to get a job is through a referral. It's true. Additionally, you can go to meetups. For me, blogging has really been an amazing way to network, and it's driven a lot of my career so far. And really, how to get in the field is something a lot of you guys are doing right now. You're getting an education. And the important thing to note is after you graduate with your bachelor's or master's or PhD, to always keep on learning. This is something that's especially true in data analytics in particular. There's always something new to learn, always a new technology, always a new programming language. It can be exhausting at times, but you got to keep on learning. One hard thing to communicate to a lot of people is the importance of learning a programming language. You're not always going to get nice, clean data delivered to you in a nice Excel file. To be able to extract data, no matter what format it is in, and put into something you can use, really matters. And obviously, SQL knowledge helps. It gives you the ability to query databases and get data in a format that you like, okay? Additionally, people use all sorts of languages to be able to transform data, okay? Additionally, in many companies, data flows, development, it's all written in a programming language. Basically, to be able to get your work into some sort of production, you have some sort of great analysis. It really helps to know programming language because a lot of times your product is written in a programming language, and to be able to incorporate your work, you have to know some sort of programming language to communicate with IT, with engineering, and so on and so forth. Additionally, let's say you really hate programming and you just want to use some sort of business intelligence tool like Tableau or RapidMiner, etc. Coding knowledge can really help you understand these tools, but also a lot of these tools allow for pseudocode inside the tools. This is something that I think is probably the most important part of this talk. If you're going to be a programmer, if you're going to be an analyst, if you're going to use any sort of coding language, scripting language, etc., you need a GitHub. The ability to showcase your work to employers goes a really, really long way. Employers look at GitHub accounts. I've had to look at resumes before for coding jobs. The people that really stood out to me are the people that had GitHub accounts, so I could look at their code, see what they know, see what they don't know. And it also shows employers you aren't a false positive. It's easy to tell someone on a resume you have coding experience, but to have something online, it really, really does help. When I was looking at resumes today, I would have loved to see more GitHubs with, nice, clean code. Sometimes they, can tell you where you can improve your code. I also use my GitHub just to keep my code in case I want to reference it later. People have reached out to me or found me through GitHub, and they've reached out to me through LinkedIn about jobs because they saw that my coding was good. This image here just shows that, a lot of times in job descriptions, people ask for the sun, moon, and the stars. But a lot of times what people are looking for is just that you can do something. And a GitHub shows that you can do something. So GitHub is basically where you host your Git repositories, where you host your code online, basically. And Git is really just a command line program where it's a version control system, and it allows you to push code to GitHub. It's way more complex than that. There's entire courses on Git. But this is an important fine distinction that you guys should probably know about. If you can use Git to push to other hosting services other than GitHub, but GitHub is the most common. For all my business intelligence enthusiasts, if you're gonna say that you know Tableau, or if you're learning Tableau, a really good thing to do is to start utilizing Tableau Public, a way to show employers that you know Tableau. If you want a good example of what a good Tableau Public looks like, I have a link in this presentation to Recia Stus's profile. And you can see, someone's quality work. This is what I honestly use on a daily basis. This is my bread and butter, basically. Python is rapidly growing in data analytics, in data science. A lot of machine learning and deep learning libraries are written for Python. It's a very compact and readable language. It's an object-oriented language. There's dictionaries, which don't worry about it if you don't need to know. There's a lot of open source libraries. So basically, if you want to do something, chances are someone has already written a script to do it, and it can save you a lot of time by utilizing these libraries. If you want to perform some sort of machine learning algorithm, someone's already written the algorithm, and it's really just easy to plug in your data and get some results out. Additionally, even if you really don't want to program, there are times in Tableau, RapidMiner, etc., where it really helps to be able to write a custom R Python script to be integrated with the dashboard. And again, you'll find it so much easier to know a coding language for a lot of tasks. It's also free. So on the right for this image, I have sklearn's 4-step modeling process. And this is something in Python called the Jupyter Notebook. And it's really easy to read, and it makes it easy to explain your code to others. Because often in business intelligence, in business analytics, it really helps to be able to explain your work, okay? Explain and justify your work, really. There's a lot of different languages, a lot of different scripting languages, a lot of different programming languages. Another language is something called the R programming language. Like Python, it's free. It is not an object-oriented language, but one of the biggest benefits in R is with Python, I talked about there's a lot of open source libraries where if you want to do something, chances are someone's already coded it already, so you can utilize their work. R has many open source libraries as well. Their libraries are more focused on statistics. So if there's some statistical test you want to implement, it really helps to know R so you can quickly implement your statistical test. And there's a lot of wonderful libraries. There's a series of libraries called the Tidyverse that a lot of people utilize. A lot of these BI tools allow you to run custom R and Python scripts, okay? So on the right here of the screen, I have an image of RStudio. This is just a place where you can write R code. RStudio does so many things. Again, if you want to work in R, people usually use R and RStudio in tandem. The next language I'll briefly review is SAS. With SAS, it is something you do have to pay for. However, it's a big however, they have wonderful technical support. A lot of times when you're learning, Python, R, etc., you run into a lot of issues because learning a programming language is a lot of work. It's a lot of hard work. The beauty about SAS is you have wonderful technical support. They actually pay people to write documentation, which is a wonderful thing, by the way. It's easy to pick up the basics. And the most important part is SAS is heavily used in government. What this means is you go to a job, a lot of times you work in the programming language that your job wants you to. That's how most workplaces work, right? And SAS just happens to be more heavily used in government. Furthermore, the FDA seems to prefer analysis done in SAS. And people usually ask me, what language should you learn? And my recommendation for people that are going to ask is to really search for jobs in your area and assess what employers are looking for. And really just try to learn some of the skills that employers ask for before you graduate. If you see in a lot of job postings in your area that you should learn Python, for example, it doesn't hurt to also know R as well, because the more skills you have, the more power you have, the more flexibility you have in your employment. The ability to ethically explain and interpret results is important, along with learning programming languages, along with learning statistics. It's really important to be able to communicate your results to people. So if you communicate your results, you tend to inform business decisions. I've seen people do amazing analysis, and when it comes time to show their bosses, to show the people that make decisions in the company, they lack the ability to communicate their findings. And the analysis is essentially gone at that point if it's not being acted on, okay? And a lot of times people use tools like Tableau and RapidMiner to disseminate the results, to show things to the decision makers in the company, okay? And I really want to emphasize this. It's great if you have analysis skills, but if you don't have the ability to communicate the findings, then it really hurts your career. So with that, I'll take questions.
Michael, the first question that we have is, what do you think is the most important thing for managers or leaders to know about data analysis?
Well, it really depends on the type of company and what industry you're in. So if you're in, let's say, a tech company, the Googles, the Facebooks of the world, managers tend to be more technical, so it's less of an issue. But I worked in a marketing company, for example. It'd be nice if managers knew a little bit of basic statistics, but part of that's also on us to be able to communicate to people, right? It takes a bit of challenge to kind of understand your boss and to be able to learn how to simplify your results to someone, okay? It's not an easy thing at a different company. It takes a little bit of time at each company figuring out, what managers, wish they, or it takes a bit of time to kind of learn at each company.
So the next question that we have comes from Cassandra. And she asks, it seems a bit overwhelming learning several languages at once. Are they pretty interchangeable?
Wonderful question. I'm a big believer, and this is a bit controversial. Get good at one language first, okay? You don't have to, know 5 languages for most, lower level jobs, okay? For example, if you look at the jobs in your area, and a lot of them are asking for Python, learn Python, and then worry about the other stuff later. Learning 3 languages at once is difficult. I wouldn't recommend learning 3 at once. Just look at what you need to learn first, what's in most job listings, and then go from there,
How do you weigh in learning something like PowerShell or Bash, scripting with learning Python?
So the ability to work in the command line, PowerShell, Bash, it's really important because, for example, Python, right? I love Python. To be able to launch Jupyter notebooks, or to be able to get to certain directories, you have to know Bash. It kind of goes in tandem with learning any language, especially Python, and especially object-oriented languages, I would say. So yeah, you kind of got to learn that as you go with different languages. And for what it's worth, I'm not a big fan of PowerShell. I typically just do everything if I'm on Windows in command prompt. If I'm on a Mac, I do everything in terminal. What you quickly find is that if you start working with Git, a lot of times people have a terminal for Git Bash. They have a terminal for Anaconda prompt, and it gets crazy. So there's ways to make it so you only have to work in the command prompt on Windows, for example.
Great. Anthony asks, what role do coding contests like Top Coder play in today's job market?
If you're doing like a strictly, programming job and not so much a data science job, that's pretty big, especially if you happen to place well. It also helps with interviews, right? If you constantly code in coding contests, you tend to be better in interviews. So I really feel like that stuff really plays well in interviews, not necessarily in getting past screenings. Especially non-data science roles, that's huge.
Next question is, how important is an understanding of regex in data science as a corollary to having grasp over a coding language?
In most programming languages, they have some sort of built-in regex. So in a lot of like string manipulation libraries, you're able to enter in regex. I wouldn't focus on regex so much because it is really rare to get a pure regex like interview question. You kind of just pick that up. You can Google it when you need to. Having grasp of a coding language is something that's probably more important as far as like the hierarchy of things you actually need to learn for the job.
The next question is, what type of projects would you like to see in an applicant's GitHub portfolio?
Oh, that's wonderful. First of all, I'd like to see a GitHub because often I don't see a GitHub. But an actual GitHub portfolio, one thing that I really like to see that just for some reason people just don't do it is they have their code in a GitHub repository. And maybe I'll send out an image after this presentation, but they don't have a detailed README of what the code actually does. So if you ever go into, pick your favorite programming language, look up some sort of library, I don't see any sort of README of what the code does, anything. So as far as like type of projects, like I did a project on web scraping, okay? Part of the reason why people actually liked it was because it was documented. I said, what I'm scraping, what kind of data I expect, et cetera, et cetera. I think it's really important to have, some project that's, personal to you maybe, but also something that's extremely well documented. I cannot emphasize this enough. I don't just want to see a GitHub. I want to see a README on your GitHub. It's not hard. It's the easier part of the task.
And then going back to Chris's question from earlier about regex, he meant it, it looks like from more of a data extraction standpoint.
So regex is important in terms of ETL, transforming your data. But there's a lot of ways to get around not knowing regex, whereas there's not a lot of ways to getting around not knowing a programming language. So many libraries in Python, R, etc. They have so many ways to manipulate strings to get what you want that it's not really extreme necessity. Okay, regex is important. There's some times where you absolutely have to do it, but I really don't want to tell people to focus on it because in the span of your amount of time and how many things people expect you to learn, it's not really a major priority. And you can more efficiently clean data with regex, but there's definitely ways around that.
What visualization software do you have the most experience for using data analysis?
Lately, it seems to be a lot of Tableau, really, especially when I was working in marketing. Marketing, a lot of government contractors really seem to love Tableau because it's interactive. It's very easy to get a basic visualization going. I've also, obviously, since I'm a Python user, I use the Python library matplotlib. It's not a very interactive library. So like with Tableau, for example, people can filter the data themselves. They can, if they go over a point, they can see some sort of hover tool. And that really has a lot of power for a lot of decision makers out there. Whereas a lot of like Python libraries aren't very interactive. So Tableau is nice to know, basically. That's all I'm saying. And I've also, sorry, I forgot to mention this. If you're strictly trying to do data visualization, JavaScript is lovely to know. People use d3.js, a JavaScript visualization library. Same thing with Leaflet. But those take so much more time to use than Tableau, and there's only a finite number of time.
If you don't currently have an analytics job, how might one become more proficient in a programming language?
Find some project that you want to do, and then just start trying to do it. When I first started learning to program, I was first of all in a master's, which a lot of you guys are in some sort of education. So have some sort of side project. I can probably send out a link later to some different side projects I've worked on. Find a side project, work on it. If you're wondering if your code's not working for some reason, you can post the code on Stack Overflow. You can post on Reddit. I often learn so much from people criticizing my code. And it really does help. Because I know, after work, if you don't work an analytics job, it's a lot to ask someone to code. But it's really needed. And if you put your code somewhere online, a lot of times people give back feedback, and that's priceless.
What do you use to practice the different types of languages?
It's been a while since I just practiced for the sake of practicing. For Python, I typically code in something called a Jupyter Notebook. And I have, in one of the slides, I have an image of what a Jupyter Notebook looks like. Additionally, there's so many tutorials for coding Python and Jupyter. In R, just to practice, I typically use something called RStudio, and that's huge. Basically, it's an IDE integrated development environment. And then, it's, as far as just practicing, I typically just do it all through, if it's Python, it's Jupyter, R, RStudio. Okay. Also, I hate to plug, but you can also use something called DataCamp. I think they have a couple of free courses where you can practice R and Python. And there's so many wonderful resources out there. It's not just, unique to DataCamp. There's so many wonderful YouTube videos on these sort of things.
How important is data analytics for an accounting major? Is there a particular language that accounting majors should learn?
Typically for accountants, a lot of times they just, flat out use Excel. A lot of them learn Visual Basic. And you can look up what VBA is after the presentation. But it's really just about learning what the employers are looking for and then trying to become more proficient in something. I would suggest, you learn, everything, but there's only a finite amount of time that you have to study or to do things, because everyone has, something they have to do outside of, learning, right?
All right. Will asks, I am interested in the field of healthcare analytics. How can data analytics translate into the healthcare industry?
There's so many things that you can possibly do. You can analyze, any sort of healthcare data. You can analyze Alzheimer's data, look for patterns, trends. It really is just limitless, really.
Charles asks, is Kaggle a good place to learn how to work with data sets? And would that be something to place on a resume?
Absolutely. The one thing with Kaggle is it's wonderful for learning, what the different strengths and weaknesses are, different machine learning algorithms. It's fantastic. It's not always real world data in the sense that I think a lot of Kaggle data sets tend to be a bit cleaner, at least when Kaggle initially started. So you don't have as much transforming the data, which is typically, 60% of the task is actually getting the data into a nice format. So you don't get that aspect. But as far as, acing interviews, if you have a Kaggle profile, certain companies definitely look for that when they hire people. One of my former companies, which shall remain nameless, they definitely looked at someone's Kaggle profile, all the time. Anytime someone sent in a resume, they saw if they had a Kaggle profile, see what they did, because it was very machine learning algorithm heavy. So I definitely recommend it. And again, the beauty of Kaggle is you post code online, people can give you feedback. You can find out what you're doing wrong. You can look at other people's code. It's wonderful.
Next question is, how does SQL fit into these languages?
Typically, data doesn't reside in CSV files. It resides in some sort of database. And SQL helps you query that database to get the data you need. Okay. I should note that there are some jobs where, yes, they'll just hand you a nice, CSV or Excel file, but there's a lot of other jobs where you have to query and get your own data. And that's a really underrated part of like a data scientist or data analyst job,
For someone coming from a programming background, what skills other than coding would you recommend someone pursue?
If you want to go into some sort of machine learning job, understand algorithms, understand how logistic regression works, how k-nearest neighbors works, how PCA works, dimensionality reduction algorithms. Understand, how all these algorithms work and when you should use one algorithm over another algorithm, really important. Additionally, if you're coming from a coding background, you have a bit of a step up, as a lot of times with data science interviews, people ask, perhaps unfairly, a lot of computer science-based questions, just as like part of the interviewing process. Some companies absolutely don't do this, but there's a couple that still definitely do, so it helps. I'm trying to think of what else is really important. Oh, so if you're going for some sort of machine learning job or data scientist job where you have to do a lot of like algorithms, accuracy is not the best metric. It's, classifying, let's say you want to classify digits, right? You classify and you find you have a 95% accuracy in classifying, digits. Typically at a lot of companies, they're looking for like where your classifier went wrong, learn about ROC curves, class imbalance, those type of things.
Since machine learning often involves large input training data sets and analyzing on multiple dimensions, was this a natural carryover from your initial work?
Initial data science jobs, a lot of it's cleaning data. I mean, really, at least a lot of places. And for most tasks, 60% of your job at least is cleaning data. And then the remaining part is, other stuff, and then trying to do some sort of predictive analysis on it, trying to extract some sort of value from the data that you're working with. As I've gotten further in my career, I'm not doing so much the data cleaning anymore. I'm doing a lot of predictive analysis. It's just a natural progression. If you do some sort of data analytics, everyone's done a linear regression, right? That is, you're trying to predict, some trend, right? Machine learning is just kind of an addition to that in a very, very simplified fashion.
Where do you find data sets for code practicing?
There's so many data sets on Kaggle that you can, download and analyze with whatever language you want, which is wonderful. There's, I think UCI has some sort of data repository, UC Irvine, I think. So there's a lot of wonderful sources there. I've even written a blog post about web scraping to get a data set that I wanted. So I worked on my Python to be able to take data from a website and then to be able to analyze it myself. So there's a lot of different ways you can get data.
Is sabermetrics a useful way to gain experience in working with data sets? Would it be good on a resume?
Depends on what industry you're trying to get into. So if you're trying to get into some sort of sports analytics, obviously helps a lot. One big issue a lot of people have is they look on someone's resume and there's no evidence of people having some sort of skill in something. So having some sort of sabermetrics project that you list in your resume will really help you. So one important thing, and this is something that I continually deal with on a daily basis, is the need to keep on learning something. Even if you get a job in some sort of data analytics or data science or whatever career you have, industry changes so fast that if you don't keep your skills current, it becomes a problem. If a couple of years from now, Python's no longer used for some strange reason, you got to be willing to learn, a different language or, different, visualization tool. If my company wouldn't be willing to pay for Tableau, for example, and they want me to do some sort of other like application or some sort of other business intelligence tool, you got to be willing to learn those tools to keep your career and your skill set fresh.
Thank you again, Michael, for your time and your insights. Thank you to all of our viewers. You can also register for any upcoming Enlightening Talks sessions from our Enlightening Talks webpage, which is csuglobal.edu/enlightening-talks. On behalf of everyone at Colorado State University Global Campus, thank you and goodbye.